number of elements or number of moles for each element. So for the number of moles in each element, for that column, for water, you're going to need two answers. I need to know how many moles of H there are and how many moles of O there are. So for the sodium chloride, I need to know how many moles of Na and how many moles of Cl. For the sugar, the sucrose, I need to know how many moles of C, how many moles of H, and how many moles of O. So you're just taking that subscript you find in the formula, and you are multiplying it by the number of moles in 1 teaspoon. That is all you are doing. Because this fraction will always be over 1. So for the sucrose one, I think it's 12 C's. You're going to take the number of moles you find in 1 teaspoon, and for carbon, you're going to multiply that by 12. For the hydrogen, you're going to take the number of moles in 1 teaspoon of sucrose and multiply that by 22. For the oxygen, you're going to take the number of moles in 1 teaspoon of sucrose and multiply that by 11. And that is the number you will get for the number of moles of each element. That is all you are doing. Just multiplying two numbers. Yes? So for the sodium chloride, they're each 1 and 1. That should be the same number. The number you get in 1 mole teaspoon of sodium chloride should be the same number of moles you get of sodium and the same number of moles you get of chlorine.
So what is what do you got now? So do you add both the numbers in time by that number?
What do you mean two numbers?
Like, you got like 2 moles of hydrogen. What if you add like
That's
2 moles?
for the, since you have 2 hydrogens, you put the 2 here. So you take in the column that it says how many moles are in 1 teaspoon, that should only be 1 number in there.
What if you had like 2 moles of oxygen?
Then you would, when you find the oxygen, you would also multiply that number by 2. So if you had hydrogen peroxide, H2O2, then when you did oxygen, you would do the same thing. You would just multiply it by 2 because the subscript on oxygen is 2. So you're looking at the formula on the far left, and you're looking at the subscripts on each of the elements, and you're just multiplying the number of moles in 1 teaspoon by that subscript. Yes? Make sense? Are you sure? Does anyone else have questions? No? If you are ahead and you finish how many moles of each element there are in your compound, the next step is to figure out how many atoms of each element there are. All you do is you take the number of moles of an element and you multiply it by Avogadro's number. 6.02 times 10 to the 23rd. That is all you are doing. So, for the atom column. By Avogadro's number?
That one would be no.
The number of the column that asks how many moles of each element there are, you're going to take that number and multiply it by this. So you'll have separate answers again for each element. So for that last column, number of atoms, you're going to have separate numbers for each element. So for NaCl, you will have 2 separate numbers. They will be the same, but you need 2 numbers. The unit is atoms. Okay, remember we talked about 1 mole. If I ever have 1 mole of something, I always have 6.02 times 10 to the 23rd representative particles. And when we're talking about a single element, what was the representative particle on an element? Anyone remember? The representative particle of an element. It's what we are finding in the last column. Atoms. The representative particle of an element is an atom. The representative particle of a compound is what? Molecules. So that last column is asking for the representative, how many particles of each element you have. So you're multiplying it by 6.02 times 10 to the 23rd. So that last column, the units need to be atoms. Yes? Everybody get this? I'll walk around and help. This is what you should be doing the rest of the period. If you finish all of the calculations, there are 5 questions on the last page you need to answer.